Are you ready? Let's learn some math. Math, 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 math. Math, 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 math. Math, 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 math.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.
Welcome everyone to our final episode of Math Matters. I am Shaka Grant.
And I am Shoya Hurst.
As shared previously, we will be reviewing some special topics to assist the primary school students in preparation for their national assessment.
Today, we'll be taking a look at time. We'll also share with you some important tips so that you can be prepared to navigate your exams.
So you know the drill.
Take a second, grab everything you need.
You can even call a friend and let them know
it's time for Math Matters.
Are you ready? Let's learn some math. Math, 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 math. Math, 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 math.
Great, so now that you're ready, let's jump right into this new topic of time. First up, let's discover what exactly is time. We're going to be looking at some images and perhaps you can come up with your own definition. We often use time to refer to the past, the present, and the future. This helps us to describe events as they happen, perhaps what may have taken place, what is currently taking place, and what will eventually take place. We also use time as a part of keeping a schedule. Very often we use calendars or devices such as a cell phone or even a hand watch or clock just in an effort to help us to be on time. In some countries, seasons mark a change in climate for a specific time of year. We should know what these are: winter, spring, summer, and autumn, all in the concept of time. We can also use time to state the specific moment an event or an activity will begin and when it will end. For instance, a birthday party, even school, a wedding, or perhaps an exam. These events can all be given a start and end time. Again, examples of the use of time. Unfortunately, there are times that we don't quite keep up with our schedule and our routines, and so we may even feel as if we are running out of time. However, if we had to define time, we could just simply consider it to be a measurement of a moment or measurement of events. It is very important as it helps us to be organized and efficient. Perhaps you may have wondered, how exactly do we measure time? If we think about it, we may often ponder, how many seconds make a minute? How many minutes are in 1 hour? We can even go as far as to say how many years are in 1 decade. Time has quite a bit of units, so let's review a few of them. Take a closer look with me and let's see how many you may even remember. In 1 year, how many days can we find? 365 days. How many months would it take to make 1 year? 12 months would give us 1 year. In 1 year, do you know how many weeks we'll be able to find? 52 weeks. 7 days help to comprise 1 week, and in 1 day we have 24 hours. In 1 hour we have a total of 60 minutes, and 60 seconds give us 1 minute. Because time has all these units, we often have to be very careful when solving problems to read, to double check exactly what unit we should be using. Always keep the context in mind as you navigate problems regarding time. Although there are many units of time, for preparation today, we want to zoom in a bit on telling and representing time on the analog clock. When we come back, Ms. Grant will walk us through telling time on the analog clock. See you when we return.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. When looking at the face of the clock, we observe two hands. There are 12 hours on a clock. The short hand always tells us the hour. The minute hand is the long hand, which tells us how many minutes past the hour or how many minutes to the new hour. In this case, the hour hand is exactly pointing at the 3, and the minute hand is pointing exactly on the 12. This gives us the time of 3 o'clock. Take a look at this clock. Be reminded that each stroke on the clock face represents 1 minute, while the whole numbers indicate 5-minute intervals. There are 60 minutes in 1 hour. One strategy we can use is to count in 5s. Let's do it together. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, and then we get to the o'clock. When looking at the clock face, we will observe that it can be divided into halves and even quarters. This can help us to tell basic times such as o'clock, where the minute hand points directly on the 12. You have quarter past, where the minute hand will point directly on the 3. We also will have half past, where the minute hand points exactly on the 6, and we'll also have quarter to, where the minute hand will point directly on the 9. When telling the time, we use key phrases like minutes past and minutes to. But just when do we use them? I'm glad you asked. From 1 to 30 minutes will be past the hour. From 31 minutes to 59 minutes, this will show how many minutes to or before the new hour. Let's see how we can tell or represent these times. What is the time? Great. 8 o'clock. We know this because the hour hand points directly on the 8 and the minute hand points exactly on the 12. We can also write this time in a variety of ways. It could be 8 o'clock on the digital clock. It could be numbers and words. You will have 8 and the word o'clock, or you can use all words and spell it out as 8 o'clock. How about this time? That's right. We have passed the hour 2 and it is 15 minutes to 3. Our hands then would show just that, 2:45. Which can also be represented as quarter to 3 or 15 minutes to 3. Let's try one more. What time is it? If we count the numbers our minute hand has passed, we see 15 minutes. We can then look at the minute strokes, which indicates 2 minutes more. So 15 minutes and 2 minutes more will give us 17 minutes. The hour hand has passed 11. As a result, our time is 11:17, which can also be stated as 17 past 11 and 17 minutes past 11. Let's pause here, and when we return, we will be taking a closer look at some strategies we can utilize in solving word problems involving elapsed time.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back, everyone. We've done quite a bit with units of time, telling, and representing time. Now we'll focus on strategies that we can use to solve problems focused on elapsed time. But just what is elapsed time? Elapsed time can be considered to be the time that passes from the beginning of an event or an activity until it finishes. Usually, we'll have the start time, the duration, and the end time. When we speak about problems that involve elapsed time, there are three main structures that we must consider. The first one being that we may be given the start time and the duration, and we're asked to find the end time. Here's an example of what that looks like. Lara started cooking at 11:45 a.m. She took 3 hours and 20 minutes to cook the meal. What time did she finish cooking? Here, we're given the start time, which is 11:45 a.m., the duration she took, which is 3 hours and 20 minutes, and we're asked to find the end time, which is the time that she would have finished cooking. This is one of the first structures we may meet when solving problems with elapsed time. There are times when we are also given the start time and the end time, and we're asked to find the duration. In problems like these, we have to consider exactly what we're being asked to find. Here's another example. A bus left the East Bus Station at 5:35 p.m. and returned at 7:20 p.m. How long did the bus take to return to the bus station? Here we have the start time, which is 5:35 p.m., and the end time, which is 7:20 p.m. So we're asked to find the duration. Exactly how long did the bus take before returning to the bus station? Our third and final structure, we are given the end time and the duration, and we're asked to find the start time. In this example, Karen has to reach her office at 8:30 a.m. She needs 1 hour, 25 minutes to travel from her home to her office. What time should she then leave home? Of course, if she's to be on time for 8:30. In this scenario, we have the end time. We also have the duration of 1 hour and 25 minutes. but we're not quite sure exactly what time would have been the start time or the time that she should be leaving home. In this case, we have to always consider the structure of the questions being asked so we can know exactly what strategies we should be utilizing. Now, let's explore some strategies we can use when solving problems with elapsed time. One of the first strategies I'd like us to explore is making a T-chart. In order to make a T-chart, the first step is to actually make the letter T. Then, once we have our start time and our end time, we need to place them in our chart. The start time goes to the very top of the T-chart and the end time goes at the bottom. Then we must determine, are we going to be adding intervals of time or subtracting intervals of time? Because we're asked to find the duration in this question and we have both the start and end time, we need to add time. Now it's solely up to you how you would add your intervals, but it is recommended that we work with friendly time intervals so that we can add correctly. In this case, let's work with a friendlier time, adding 3 minutes to 11:07, and our new time would now be 11:10. Once we add intervals, we write it on the right-hand side of our chart, and then we write the new time on the left-hand side of the chart, and we continue in this fashion. Now that we have a friendly time of 11:10, we can keep adding intervals of time because we're not at our end time of 11:42 a.m. as yet. So let's keep adding. We can now add 10 minutes more. So 11:10 plus 10 minutes gives us a new time of 11:20. We can add again 10 minutes more. 10 minutes to 11:20 gives us 11:30. 11:30 plus 10 minutes more gives us 11:40. But we're not yet at 11:42. However, we don't need to add 10 minutes more. We now need to see that the difference between 11:40 and 11:42 is a total of 2 minutes. So we can add 2 minutes more and arrive at our end time. But we're not done yet. The question asks, how long did he bake the cake for? The very next step after adding intervals of time is to add all the intervals that we would have used to get the duration. So we would then add 3 minutes, 10 minutes, 10 minutes, 10 minutes more, and 2 minutes, giving us a total of 35 minutes. So our answer statement would finally say that he baked the cake for 35 minutes. And here we have using a T-chart to find the duration. Note and keep in mind that this strategy can also be used for finding the start time or the end time. It all depends on the context of the question. Let's try another strategy. Here's another problem. Sports day starts at 9:15 a.m. The sport activities finish 4.5 hours later. When did the sports activities end? What exactly are we trying to find in this question? Is it the start time, the duration, perhaps the end time? Think about it. That's correct. Right in the body of the question, we have a keyword there. When did the sport activities end? Here, we're finding the end time. What strategy then can we use in this case? The second strategy I want us to explore is called a Z-chart, or Z, all up to you depending on your preference. The first step is to make the letter Z or Z using lines as we have just seen. Then we're going to write our start time at the very beginning of the letter and our end time at the end of it. In this case, we don't know what our end time is, so that's what we're going to be finding out. Just as with our T-chart, we then must determine, are we adding intervals of time or are we subtracting intervals of time? In this case, we're also going to be adding intervals of time. We have a start time of 9:15 and we need to arrive at the end time, that is 4.5 hours later. Now, one of the key things we must remember with a Z-chart is that the intervals of time that we add must be broken down into 3 simple steps. We cannot add more than 3 times with the intervals. So we are looking at 4.5 hours to be added. How do you think that we can break that down into 3 intervals of time? Here's my recommendation. We can begin with 2 hours, which would then take us to a new time of 11:15 a.m. We can then move on to add 2 more hours, giving us a new time of 1:15 p.m. Finally, if we look at what's left, we added 2 hours and another 2 hours. A total of 4 hours have been used already. What then is remaining? Correct. We have 30 minutes or half an hour left. When added to 1:15 p.m., we get a time of 1:45 p.m. Here, we have found the end time. Our answer statement could then read that the sport activities ended at 1:45 p.m. In this case, we have just solved the problem, finding the end time using the Z-chart. Now, there are times when we are not given the start time or we are given the end time only with durations. It all depends. The steps then would change based on the context of the question. We can also review if our answer is correct by simply adding all the intervals of time that we use, whether to the end time or the start time, to see if we get the same answer once again. Our final strategy that we will try is called a number line, but let's read the problem first. A movie finishes at 8:20 p.m. It was 2 hours and 35 minutes long. What time did it begin? Once again, we must ask of ourselves, are we solving to find the start time, the duration, or the end time? Within the body of this problem, we have a keyword that gives us a hint as to exactly what we are finding. The word begin is that hint. So we're going to be finding the start time. When we're using a number line, the very first step is to draw an open number line. Once we have the start time, it goes at the beginning of the line, and the end time goes to the very end of the line. In this case, we're not sure as yet what our start time will be. However, we have the end time and we also have the duration. Just as with the other strategies, it is always best to break the duration down into workable intervals, making it easier to add or subtract time. In this case, will we be subtracting or will we be adding these intervals? Think about it. Since we don't know what our start time will be, but we have the end time and duration, we need to subtract the time intervals. We can begin by using a simple interval of 20 minutes, allowing us to arrive at a time that is easier to work with. When we subtract 20 minutes from 8:20 p.m., we arrive at a new time of 8 p.m. When using the number line, it is important that we pay attention to the jumps. Smaller jumps are used for minutes and larger jumps are used for hours. When documenting our intervals and our new times, whatever we subtract or add goes to the very top of the peak or curve, and our new time goes below where the curve or the peak may end. Here we have 20 minutes represented and our new time of 8 p.m. Since we had 35 minutes in the duration, we can then subtract that 20 minutes from the 35 minutes, and so now we're left with 15 minutes. But rather than subtracting it all at once, let's break it down even further. We can take away 10 minutes in our next jump. And so if we subtract 10 minutes from 8 p.m., we arrive at a new time of 7:50 p.m. Then we're left with that 5 minutes. When taken away from 7:50 p.m., we arrive at 7:45 p.m. Now we have an interval of 2 hours to account for in our jumps. Let's not do that all at once either. Let's break that 2 hours down so that we can have 2 jumps of hour intervals. Notice the larger peak? That's how the hours should be represented when using the number line. We subtract 1 hour, and so 7:45, and we take 1 hour from it, we arrive at the time of 6:45 p.m. There's 1 hour left, and when taken away, we arrive at 5:45 p.m. If we look at our number line, we're able to see that our start time was indeed 5:45 p.m. So to answer the question, what time did the movie begin? The movie began at 5:45 p.m. These 3 strategies can be very useful when solving problems for elapsed time. They can all be used to find the start time, the duration, or the end time. We must always be sure to read our problems carefully so we can select the right approach of adding or subtracting time, knowing what we're asked to find. Don't go anywhere. We'll be right back.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back, everyone. We've learned quite a bit about time, representing, telling time, and solving problems with elapsed time. But before we go, we just want to leave you with some exam reminders so you can be adequately prepared to navigate your exams. Perhaps you may be wondering, when will these national assessments take place? Well, the Grade 2 and 4 national assessments will take place on May 23rd. For the Grade 6 students, your mathematics exam will be on the 6th of June. It's not too late to get ready and prepared, so practice and be ready now. Here are some things that you always need to remember to do. Always remember to
read instructions very carefully.
Answer all questions. Don't leave anything blank.
Show the necessary working required in the spaces provided by drawing, working it out, or writing about it.
Also, when drawing shapes, lines, or angles, always use a ruler. Don't do it free-handedly.
Grade 6 students, when using a calculator, your working will simply be whatever you input into the calculator written in the space provided.
If you're unsure about something, seek clarity. The invigilators are there to assist you.
Be very careful with order of operations.
Let's take this question for example. Solve 6 plus open bracket 21 minus 17 close bracket times 3. Would the answer be A, 30, B, 18, C, 15, or D, 13? The answer in this case would be B. Now you may be wondering, how did we arrive at that answer? Well, first, we must do what's in the brackets. Then we'll have 21 minus 17 giving us 4. Multiplication will take place next with the very same 4 times 3, giving us a product of 12. We will then add that product of 12 to 6, giving us a final answer of 18. In questions such as these, for order of operations, always remember BOMDAS. Brackets first, and then we can move on to multiplication or division, addition or subtraction. Very often, students make the mistake of thinking that multiplication is more important than division and addition is more important than subtraction. But we must remember that we solve from left to right even when both are present. Regardless of the order they may come, multiplication, division, addition, and subtraction, we solve from left to right. Be very careful when using BOMDAS in order of operations.
Always remember to use your time wisely.
And finally, we can only ask you to do your best work. Ensure that as you attempt all questions, you give your very best effort. Thank you for joining with us through this episode. We are confident that you'll definitely conquer those assessments. And to those who would have participated through this season, submitting responses to challenge questions, you did an awesome job. Please continue to keep in mind that you can still submit for the previous challenge question to mathmatters268@gmail.com. We will inform you of when you will be awarded with your prizes.
Don't forget, keep practicing and we will see you at the next season.
All the best once again, and always remember, math matters. Have a wonderful evening.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.